All right, let's just jump right in. Today, we're going to talk about one of the most frustrating things in AI development, memory. We're looking at a tool called Mumpix, and its core idea is actually brilliantly simple. What if AI storage just worked like SQL?
And this quote, it just nails it, right? If you've ever built an AI agent, you know this exact feeling. The agent that completely forgets what you told it 5 minutes ago. Or you run the same prompt a day later and get a totally different answer. It's this feeling of unreliability that really holds AI back from feeling, truly robust. In this slide, wow, it puts some hard numbers on that feeling. Just take a look at that benchmark. The orange line, that's your standard AI agent. And its accuracy just drops off a cliff after only a few sessions. We're talking all the way down to a miserable 14.3%. Meanwhile, the green line, that's Mumpix, is just locked in at a perfect 100%. It just doesn't forget. This is AI amnesia, right there on a chart.
So, okay, how do you fix a leaky memory like that? Well, Mumpix has a solution that's going to feel instantly familiar to millions of developers, because it draws its inspiration from one of the most trusted tools in all of software. So what is Mumpix? It's basically an embedded, local-first database file that's designed from the ground up for AI. The keywords here are real infrastructure. Instead of some fragile, unpredictable black box, you get storage that is predictable, portable, and something you can actually, trust in production. And getting started couldn't be simpler. It's totally zero config. There's no cloud setup, no dashboards you have to configure. You literally just run npm install Mumpix, and you get a single file with zero external dependencies. The database file itself is the API. It's that easy.
This slide just perfectly illustrates the before and after. On the left, you've got the chaos. Agents that forget things, vector databases that can't promise reproducibility, plus all the latency and cost that comes with cloud stuff. And on the right, you have the Mumpix outcome, a simple embedded database that works offline, gets you better results with hybrid retrieval, and even has a verified mode for audit logs, all with zero infrastructure overhead. It's just calm, predictable storage.
So this all sounds great, but the crucial question is, how does it actually achieve this reliability? Let's dive into the technical details that make Mumpix truly infrastructure grade. It all starts with crash safety. Mumpix uses a classic battle-tested protocol called a write-ahead log, or WAL. Here's how it works. First, any new data is written to a temporary log file. Only after that's done is it appended to the main database file. And finally, the log file gets deleted. What this means is, even if your entire system crashes mid-write, a record is either fully present or completely absent. You never get a corrupted, partially written state. Ever. And what's really cool is you can choose your level of durability. The default eventual mode is super fast and perfect for prototypes. Then, strict mode syncs every single write to disk, which is what you want for production agents. And then there's verified mode, which adds an immutable audit log. This is for the serious stuff, think fintech or healthcare, where you absolutely have to prove why an AI made a certain decision.
But Mumpix is so much more than just a memory store. Its features really make it a complete solution. The database file itself is portable. You can just ship it with your app. Its search is a powerful hybrid of exact keyword matching and nuanced semantic search. We already saw it. It offers verified consistency for audits. And this is huge. It has drop-in adapters for the tools you're already using, like LangChain, LlamaIndex, and Crew AI.
Okay, so we've established it's a fantastic tool for back-end agents. No question. But what if we could take all of that power and move it beyond the back-end? This is where things get really, really interesting.
That's right. All that power, all that rock-solid reliability isn't just for your servers. Mumpix can run entirely on the front end, directly in the user's browser. This completely changes the entire architecture for how we can build web-based AI applications. And it enables this beautiful, simple local-first AI pattern. Think about it. The user interacts with the UI, the agent reads its memory locally from Mumpix, it generates a response, and then it stores any new knowledge right back into that local memory. Everything happens right there in the browser. No database server is required at all.
The benefits here are just huge. First off, speed. No network latency means queries are instantaneous. Your app also gets offline capabilities, so it feels intelligent even without a connection. Third, it's private by default. No personal data ever has to leave the device. And maybe most importantly for the user experience, agents can finally remember users across page reloads, which creates a real sense of continuity.
So let's just zoom out for a second.
We've seen how Mumpix makes AI reliable on the back end and how it unlocks all these new possibilities on the front end. So what's the big takeaway from all this? Why does it matter?
This is the big idea right here. Just like how SQLite became this invisible, totally reliable database inside millions of desktop and mobile apps, Mumpix is aiming to become a fundamental building block for the web, a local primitive for AI memory. It's not just another library, it's a whole new architectural layer.
So, to sum it all up, Mumpix provides the foundation to make AI predictable, reliable, and trustworthy. And it does this everywhere, from those powerful, long-running agents you have on your servers all the way to fast, private, local-first apps right in the browser.
Which really brings us to our final question. It's one that I think every AI developer should be asking themselves. As you're building this next generation of intelligent software, take a moment and think about its foundation. Is your AI's memory built to last?